Welcome to the latest installment of the Aras Innovator Demo Series. Today, we are going to see harnessing engineering data to create connected process plans. The demo series runs for 30 minutes and features all demo with no sales pitch. Each installment showcases a different capability of the Aras platform. During the webinar, everyone is on global mute. If you have any questions, please submit them in the questions panel within GoToWebinar, and we'll answer as many as possible in our Q&A session at the end. This demo is being recorded, and when the recording is available, you'll receive an email with the link so you can share it with your colleagues or review it again for reference. We have on the line today Craig Curry, Product Manager here at Aras. Craig, take it away.
Thank you. My name is Craig Curry, as mentioned, and I am the Product Manager for Manufacturing Process Planning, which is the capability that we'll talk about today. Before I get into the actual demonstration, I would just like to share a few slides to talk about why we developed this product and what's in it. So first of all, some industry challenges that we heard from our customers, that they have disconnected processes from between engineering and manufacturing. So they tended to create MBOMs, or manufacturing bills of materials, manually. So in doing so, they typically had no reconciliation method between the MBOM that was created and the engineering bill of materials. There was no synchronization between that manufacturing bill of materials and the actual process plan that was created to produce the part or parts. The same was true for work instructions. There was no synchronization of when you make a change to the plan, how do you update the work instructions and keep them in sync. So really what we do is provide a digital thread for all this information from as designed to as planned, and previously that traceability was not maintained, which led to having unmanaged manufacturing data in various silos everywhere. So where does this fit into our view of the digital thread? So we have various structures here that we're looking at, all the way from conceptual design through the launch and manufacture. And we have various products that we offer in our portfolio to solve these, or to address these particular areas, all the way from requirements engineering through to our new MRO capability. And what we'll be talking about today is manufacturing process planning. A couple slides just to show you what it's about, and then we'll get into the demo. It consists of a combination of being able to author the process plan and work instructions and do that in the PLM environment. So you're not doing it somewhere else and then saving it. It's all incorporated into what we call Aras Innovator, our PLM platform. When I say MBOM, I mean Manufacturing Bill of Materials. Is an MBOM editor, which is can be used just to create the MBOM, or it can be optionally linked, as we'll see today, to process plans. And we also tie to the engineering BOM so that we can do reconciliation between the two. So a little bit about process plans. They're version controlled, right? So we have a process plan consists of different operations, which would consume things like parts, documents, machines, per operation. They have also steps. You can put instructions in there. So you can utilize resources and consume parts. So resources examples would be the machines that you might use, tools that you might use. Also bring in reference documents, skills that might be required, such as a level of operator or a level of, say, a machine operator or assembler, that kind of thing. And another part of it that I'll show you is a workbench. So the idea behind a workbench is that we provide an area of the screen which allows you to take frequently used objects in Innovator and drag and drop them. So kind of an analogy of your workbench at home. You're going to do work on a project, you bring out some tools and you put them on the workbench and you use them over and over again. Same kind of concept here, except we're doing it graphically. We can create subplans, so you can build this up from the bottom if you want to, or from the top. So you could create a subplan, which I'll be showing you. It allows you to either come from a top-down or bottom-up approach. Another part of it is work instructions. So we can currently, as we're building the process plan, we can be authoring work instructions, which are, textual and graphical information for the end user or the assembler on the shop floor. Okay, these can include text, media, tabular content, which all gets developed automatically as you drag and drop different components in. Once we're done with that, we can create these visually rich work instructions and then publish them. So we can publish them to a PDF or to a web format. Also allowed to or can view alternates, substitutes of the consumed parts. And if we move on to the MBOM side of things, this is also version controlled. It's derived from the engineering bill of materials, and we have drag and drop restructuring. So typically your engineering bill of materials is not going to be identical to how this might be assembled on the shop floor. So what we can do is drag and drop, create different subassemblies, which become consumed parts, and these get consumed in different operations or multiple operations, perhaps in different process plans, and then get put together at the end. As I mentioned, there's also reconciliation. So this is real time. If you have multiple people working on different areas of the overall plan, then as they do something, they'll get notified if they've got a conflict with what you're doing. And we have icons that will show up here in one of the columns that tells you things like if its part is underconsumed, overconsumed, split, not accounted for, those kinds of things. And you can, of course, create phantoms, consumables, because there are parts in the MBOM that don't necessarily exist in the engineering bill of materials. So they could be MBOM only parts. They could be a phantom assembly, which isn't going to actually be put on the shelf and sold, but might be used as an interim. And also you can view the make-buy status of them, the revision of the parts, and version change status. Lastly, we also allow creation of plant-specific or location-specific bills of materials and process plans, so that if you manufacture something in one plant and it's a different set of steps or maybe even materials than another plant, then you can use the same top-level bill of materials and process plan and then split them out into sub-process plans, which are different. So with that, I'm going to move on to the demonstration. I'll bring up Innovator, and I'll go through maybe a little bit of a layout here. So this is Innovator, in which we would have all the parts, bills of materials, assemblies, process plans exist. We have the table of contents here. I'm going to be focusing on the process area, which consists of graphics, locations, machines, and process plans, so forth. There are other areas depending on what, these are all a series of different applications. Design, for example, is used for the engineering, part design, documents, if you're using document management, and so on. So we're not going to go through those today. There are other seminars that will either be coming up or you can view that are already recorded to get into details on that. I'm just going to move right into the demonstration and talk about the process planning. So I've brought up a process plan that's partially created. I'm going to talk about it a bit, and then I will illustrate how you actually go in and build and add on to that. So the first, what we call the view sidebar here, the first view is the form itself. And there's some basic information here. These are text fields that, example, that you can type into. The process plan number, this is the identifier of it. And then we have two tabs down the bottom, which are standard tabs in Innovator called relationship tabs, which we have a produce part, and this is what gives us our engineering bill of materials. And then we have locations, and locations would correspond to the plants that you might have. So we have them defined as cities. They could be, plant 1, 2, 3, however you need to define that. And we'll show you how those play with this or interact with it in a little bit. So the next tab down is the actual process plan itself. So I'll just first go through these different views and then explain them. So here we can see the top level. We have it divided into really three main areas. This tree structure, which shows us the operation list at the top level, and then we can open these up and, for example, see would be steps underneath it, and then parts that are consumed in that, any tools that are used. And if there's a part that's a subassembly, we can expand it further, and we can see, oh, okay, so this subassembly is actually produced by another process plan, which I could get down, and I could open that one separately in a different tab, for example, or if I just want to see some information about it, I can navigate down through it. So this is the idea of having a top-down, bottom-up approach. You can either build these first and link them in by bringing in the assembly that they produce, or you can start from the top, which is what I'll show you today. So these consist of operations, steps, graphics over on the right. So that's the left side. I'll come back to it. On the right side, we have what we call the work instructions. So for each operation, and you don't need to do this, you could just create, for example, a bill of materials, but the idea is that you could also create work instructions at the same time. So for each one of these, for example, you can, let me go down to step 40, step 3. So they're tied together. So if I select on that, you'll notice over on the left, it opened up my step 40, step 3. So these views are tied together. And then lastly, the view on the bottom is the workbench itself. So this is where I could bring in tools that I might want to use. So I could say I want to add some tools to this. I haven't brought anything onto my workbench yet. So we could say, I just got some basic tools here defined, and we can pull them in. And now when I want to use them, I simply drag them up. I won't do it here, but I can insert them into the various operations. So that's how that works. And I'll come back to this process plan view in a moment. I just want to go through the different other views. The next one I'll talk about is the manufacturing bill of materials. You can see at the top level, we have nothing but phantoms defined. So these don't exist in the engineering bill of materials. However, they were defined as being assembled in a separate process, so they're defined as a fan assembly, a phantom, and then we can expand them and see what's underneath them. Another thing you may notice about this is that we have some of these rows are color-coded or color-shaded, bringing your attention to them. So I'll go through some of these columns first. So that the type is whether it's an end component or a phantom or an assembly, quantity, of course, what operation it's consumed in. So when you drag a particular part into an operation, that's considered consuming it in that operation. And then depending on the quantity that you would use in that operation, it would deduct that from the engineering bill of materials quantity. The next column is planned. This is telling us whether there's actually another process plan for it itself. So all of the phantoms have process plans. Part status shows us if anything is out of date, we'd get an indicator here whether the version of the part changed or whether the actual revision of the part changed. So version means somebody's working on it and just making individual changes, which you may or may not want to see. Revision would be more important. But this gives you the capability to start building these process plans prior to all the design work being complete, and they can be updated as you go along. Last column is reconciliation. As I mentioned, these tell you things like the difference between the EBOM and the MBOM. So this is telling us that we have only partially consumed them, which may be fine. I haven't used them all up yet. The EBOM's 2 and the MBOM's only 1 at this point. This tells us if it's split and used in different places. If it's not consumed, some of these other ones have. I don't see any here. Let's see. No. I'm not finding it at the moment, but we have other indicators for illustrating if a part is not actually, let's look at the EBOM. That would probably be a better place for that. Right. So here is the last tab, the EBOM. So this is the same parts that we were just looking at, except they're as they came from design, and they would not have any phantoms in them. And if it was underconsumed in the MBOM, then it's going to show as overconsumed here. This is saying it's not accounted for in the MBOM, so none of them have been used yet. And I think we've covered all the other ones. So let's go back to the process plan view and spend a few minutes and just illustrate how this works. So I'm going to add a few operations. Let's go in, and in order to do that, these are all driven by a schema. So for example, if I'm at the top level, you can see that I could insert an operation, and that would put it in before 10. If I'm highlighted here, then I've got a whole different list of context-sensitive menu options, right? I can now, since I'm in an operation, do a lot of other things. Besides add, I could go in and we'll use some of these. I'll actually show you. So let's add one, call number 60, which is the next one in sequence, and I'll call this the motor assembly. I'll just pick off my cache here. So as not to spend too much time typing, I'm just going to copy and paste these for this, and then so we can. I'm just going to pick values, but let's say that we can. So we're recording here the setup time for this operation in terms of minutes and the cycle time. So once we're done with that, we have an operation, not much more. You'll see it added it to this visual work instructions, but there's nothing under it yet. And let's go in and add one more, and I'll add it in the wrong place. So let's say I want to add final assembly. And packaging, for example. And again, I'm going to, in the interest of taking too much time typing, just reuse this information here. Okay, so I'll just skip some of this. But if I determine that I put it in the wrong order, then I can just simply drag and drop it and reorder these, right? So I could say if I want to edit this, let's make it 70, for example, and reorder this one. Well, I've already reordered them. Let's just make it 60. So depending on, the idea is, by default, and you can control this, it numbers them by tens. This gives you the opportunity to go in and add 9 more in between if you find that you need to do that on some revision. So I'm going to go into the motor assembly, and let's insert a phantom. We'll just go through and build one really quickly. So I'm going to insert a phantom. I'll call it 2678 is my phantom part number. And I'll call it a motor, right? And once I do that, I can then go in and create a process plan for that. So this is going to bring up a new process plan, and I'm just starting one from scratch so you get an idea what it looks like, right? So I'll just call this the motor assembly. Again, I'm going to pick things from my buffer that are already here, so I'm not spending too much time on typing. So our produce part is the motor. We can select from the locations. I could add the other one or multiples if I wanted to. We'll just stay with one for now, okay? Because we'll, in the interest of going through this, right? So I want to show you as much as possible. Let's go into the process plan itself, and I'll show you how you would build this, right? So the first thing I'd like to do is go ahead and save it. And once it's saved, we're going to move to the process plan itself, and let's say we want to insert some parts into this that we're going to consume, right? So first thing I need to do, of course, is insert an operation. I'll say pick parts, and I'm not going to fill in any of the other pieces. But now we want to go in and select some parts. So what parts are we going to use for this? So I'm going to pick, this is now the standard search. So we'll type in, or I could search, but I think it'll be faster if I just type them in, since I know what they are. So I'm just putting multiples in here to find. And once I've done that, we can just search for them. Of course, it finds them because I knew they were there. And I'm going to select them and add them in, right? I could add them to the workbench too if I wanted to, but you can see that When I do that, it places them under the operation here, so it's showing that in the tree, and it also puts them in for my operator information. So I have things like quantity, which I can change in any one of these places, right? So let's say I'm going to need 1 motor, 6 bolts, not 11 motors. And what am I doing here? Typing the wrong numbers in, sorry. It doesn't really matter for purposes of what I'm doing, but let's just make it correct. So when I do that, if I were to go ahead and look elsewhere, for example, if I looked in my MBOM, you can see that I'm building up an MBOM at the same time. So I have this top level, which is a phantom, and I've just put in these 3 components underneath it. Right now they're all consumed in operation 10, which is to pick them, and the quantities. I mean, I could change the quantity here, I could change it on the sheet, I could change it in the tree. Everything is tied together like that, so you can be working in multiple areas. So now how do we go in and add some information to this? Let's go in and maybe add one that's more realistic for doing something. I'll add an operation called assemble motor, and leave it at that, and then we'll go in here. Now this is all controlled by a schema, so when I say I want to edit this, you can see that this is the schema that's out of the box setup. I can add phantom parts, skills, steps, resources. For example, if I wanted to add another step here, I could say, pick motor up. Let's say place drive gear on stepper motor, all right, for a step. And we go ahead and save that, and I'll just add one more step. And then place in bin. So we'll make it pretty simple here. All right. So I can also include things like, for example, graphics if I wanted to insert some text here or a list. These are all controlled by a schema that's defined by the system administrator. The idea here is that you would get everything together and organized into the way that you want them all to show up so they're all consistent. Everybody's using the same schema. All right, so I'm going to, let's go in and add quickly a resource. Right, so a resource could be an example of a skill, for example, or a tool. So let's see, we're going to use these 2. Okay. Again, you can get the idea that everything that I do gets added to both the tree and it will show up in the operator output. So quickly we'll go in and say I can add some text, for example. Okay, in order to so I'm going to make up a number for the fixture. So you can put in text, you can add graphics, lists. So I only add a couple of these. We could spend a lot of time just on all the capabilities here, but we don't have it in our overview, so we don't have the time for it. So just going to give you an idea. So again, that's creating some quick graphics and bringing in some information. And I've shown you other types of things. You know, if you want to get into more detail, we can do that, of course, at a different time. Let's go in now and save this, and then go back to the actual one that called it in, and we can now see that it has added this in here. And so the last thing I'd like to show is to go in and publish this. So in order to publish it, we would select the type of output we want, whether it's PDF, HTML, whether we want it to show it in the browser or we'd like to save it, which we can then add it and attach it. So this is the output. And by picking these various settings, you know, for example, I might want to create the output, but then attach it to the process plan in one of its tabs so that I have quick access to it. And once that's done, It shows up in a browser since I've asked for PDF, and we can then see the output of what we've done. We're running out of kind of low on time. I just want to quickly touch on one last topic, which is to look at an operation. For example, we can see that this operation 20 has this sub-process which has a couple of steps in it. If we switch this to Toulouse, okay, let's save this first. Okay, maybe I won't do that. I think I've created a phantom that already exists, so I'd have to change the name, and we're sort of out of time. So what I was going to show you is that by switching to a different location, you can toggle between the operations and see that, in Toulouse, this might be 3 different operations with different steps in them, so they can vary by location. So with that, let me move back to the presentation, and I think we have time to open it up for questions now, a few minutes.
Yes, thank you, Craig. Make sure to enter in any questions you have into the questions panel. We already have a few submitted ones. Craig, is everything you've shown available as a free download?
Everything is available without a subscription except for the PDF creation. So that requires a royalty and license. So that's the one. You could output a HTML but not PDF.
Great, thank you, Craig. Can you add videos into work instruction on the right-hand side inside the steps?
That is something that we've recently added to TechDoc, so we will be incorporating that. I don't have that capability in this version, but yeah, that's something that the right side, the work instructions, is based on another capability, which the product is called TechDocs, but it's based on something called the framework, or TechDocs framework, and that capability has been added there, so we will be adding that in the future.
Is there any way to connect the MPP to SAP routings, etc.?
There's not anything out of the box, but we have many customers that have done that. They've built screens. Innovator is very customizable, and they've gone in and pulled information from different, like an SAP or different ERP systems, and pushed it out as well, but not out of the box.
We have time for one more. Can I use this to configure an MBOM without the work instructions?
Yes, you can. You would basically, if that's all you were after, you would create one operation and per assembly, and then drag and drop the parts from the workbench. I didn't illustrate parts too much in the workbench, but you could show all the engineering parts and drag and drop them up to create the MBOM that way.
Great, thank you. And thank you all for your questions. For any we didn't answer, they will be addressed directly within the next few days. I'm going to leave you with our upcoming demo series topics. On February 13th, there will be a demonstration on managing documents leveraging Microsoft Office Connector. And then on February 27th, there will be a demonstration on Aras Requirements Engineering, making requirements part of the digital thread. You can register for upcoming demos and view any past demos at aras.com/demoseries. We'd love for you to join the Aras community at community.aras.com. There, you'll find blogs, community projects, and forums, all with a lot of great information. Be sure to connect with Aras on LinkedIn, Twitter, Facebook, and Instagram, where we will share the latest updates and news, product information, and more. Finally, don't miss our annual ACE conference this March in Boston. We love to see you there to answer your questions, get your feedback, and take the opportunity to network with the Aras community, the Aras team, our partners, and more. I'd like to extend an exclusive discount code to you. Enter the code DEMO10 when registering to receive 10% off. We thank you for joining us today and look forward to having you visit next time. Have a great day.